Determine the moment about point B of each of the three forces acting on the beam. Okay, so here we have another little bit of a different problem than what we're used to. Instead of finding purely the reactions on the beam or the object to keep it in equilibrium, we're just simply finding the moments created by these three forces right here. Okay? So, and also another important thing to notice right here, at B, we actually have a width to this beam. So this is no longer a widthless beam. We'll be using a beam with a width. And it's going to affect our calculations a little bit. We shouldn't be getting some different components that we normally wouldn't have to compute. So we'll see that a little later. So define variables as always. Actually define what we're looking for in this problem. First one's going to be the moment that the first force is creating about point B. Same with the second one, the second force, and same with the third force. All is finding the moments that they're creating. Okay? Let's draw a little diagram for force 1. So if I draw point B right there, the axis of rotation, draw the lever arm to force 1. And moments are purely or path independent process or property, I guess. That means it's only the distance that affects the moment created. So we can simplify the beam to a line in this case. Okay, so it's going to be 375 pounds acting 11 feet away from point B. Okay, and then the moment the first force creates, going to find the positive as the counterclockwise direction right here. So the force is 375 pounds acting 11 feet away from point B. Should find that is 4,125 pound-feet of torque. Can now be a first variable. Pound-feet. Okay. And I'm moving on to force 2. Again, a diagram. Always start with a diagram or free body diagram, whatever you need to correctly display the problem. Okay. So we're going to have this force, an angled force right here. It's going to be a 3-4-5 triangle. 3, 4, 5, and 500 pounds of magnitude. And it's going to be acting 5 feet away from point B. Okay, and we know the vertical component right here is going to be the only part of the force that creates a moment, because the horizontal component right here isn't going to have a moment arm. Take the horizontal component of that force, there's going to be no moment arm to create a moment. Okay, so same deal right here. Positive direction will be counterclockwise in accordance with the right-hand rule. And we know the force is 500 pounds. It's going to be a positive moment because it's going in the counterclockwise direction. And we're going to use a fraction 4/5 to find that vertical component that we need. This will be applied at 5 feet from point B. Should find that it's equal to 2,000 pound-foot of torque. Okay, and now we're looking at the third moment and the third force created. So, same deal. Instead, we have a very short vertical little moment arm right here, 5 feet away from the force applied right here. Be applied at a 30-degree angle right here and 160 pounds of magnitude. We got point B. And so here is where that width to the beam is going to become important. So if there is no width to this beam at all, and just at point B, there'd be no moment created. But since there is a little bit of a width right here, then it's going to create a small moment. and only one component of this vector of this force will be creating moment. In this case, it's going to be this horizontal component because this is the only component to this force that creates a moment. Okay? See right here for this vertical one, there isn't any moment arm. And we can really look at the definition of a cross product to see why that exists. So we know the definition of cross product is going to be R cross F equal to a moment. We also know that the magnitude of R multiplied by the magnitude of F sine theta is going to equal to the moment as well. Okay, and this is only be the magnitude of these vectors. So we see this sine right here. That is the angle between the moment arm vector and the force vector. And so when sine is equal to 90, we know that sine is going to be 1. That's going to be the full magnitude. But if sine's at 0, or 180 in this case, sine's at 0 or 180, sine's going to be 0, making no moment. So that's this kind of definition of the cross product, kind of to explain why a little bit more. But back to the problem. Moment 3, counterclockwise is positive right here. We know the force is going to be 160 pounds. It's going to be a positive moment using the right-hand rule. And to find the horizontal component of this force, we're going to use sine 30 degrees. Okay, and even though we're looking for the horizontal component of the force, it's going to be sine based on where the angle is in reference to. Now, if we had this angle right here, it was given this angle, we could find this angle, obviously, but we're given this 30 degrees right here, so we're going to be using the cosine function. No, sorry, sine function, because this is the opposite side of the triangle that we're finding. We're using the sine function, but if we had this angle to find, then we could use the cosine function, because then it would be adjacent, the x component. That's a force right there, and it's being applied at half a foot away, and should find that is equal to 40 pound-foot of torque. Okay, and that'll be our third and final find variable. That's it. We're done.